Okay, Chapter 4, Lesson 1, Part 3, Solving Systems of Linear Equations by Elimination. Go ahead and pause to take these notes. And I have for the examples, remember to look for one solution, no solution, and many solutions. So in each of these cases, when we're solving for these, we want to make sure that our variable that we're solving for has the same coefficient, but one is a positive and one is a negative. It makes them cancel out. So looking at example 1, I have negative 2x on the top and positive 2x on the bottom. By elimination, they will cancel each other out. Then I solve what's left. That would give me 9y equals 3, so y equals 1/3. Once I have one of my variables, I go ahead and put it in my solution, and I'm going to substitute that into the top equation in the y spot. So I'm going to rewrite the top equation as negative 2x plus 3 times 1/3 equals 0. So negative 2x plus 1 equals 0. Negative 2x equals negative 1. And x equals 1/2. On the second example, I'm going to go for the y's to get the y's to be the same. I would have to multiply the top equation by negative 2. That way the top equation becomes a positive 2y and the bottom one will stay a negative 2y. So my top equation then becomes negative 12x plus 2y equals positive 10. And notice I'm multiplying the negative 2 by all of the terms. My bottom equation then stays as 4x minus 2y equals 6. My y's will cancel out. I'm left with negative 8x equals 16. So x equals negative 2. Now I take that and I sub it into the top equation. So that gives me negative 12 times negative 2 plus 2y equals 10. So 24 plus 2y equals 10. So 2y equals negative 14. And y is negative 7. On this third example, I think I'm missing the x. Sorry about that. So I'm going to go ahead and try to get my x's to be the same. And so in order to do that, I'm going to go for 12. That means I'm going to have to multiply the top equation by 2 and the bottom equation by negative 3. That'll make my top a positive 12x and my bottom negative 12x. So my top equation will become 12x minus 6y equals negative 6. And my bottom equation will be negative 12x minus 15y equals positive 27. The x's will cancel, and I'm left with negative 21y equals 21. So y equals negative 1. Then I'm going to sub that into my top equation. So my top equation will become 12x minus 6 times negative 1 equals negative 6. So 12x plus 6 equals negative 6. So 12x equals negative 12. And x equals negative 1. On this next one, I'm going to multiply the top equation by 3 so that my top equation becomes negative 3x plus 9y equals 18. And my bottom equation will stay 3x minus 9y equals 9. Now when I solve, these two will cross out, both of them. And so I'm left with nothing over here equals 27. which is not true. So as I said in the beginning of the slide, make sure you check for no solutions. That's telling us that these two lines here are parallel, and so there's nowhere that they cross. On this last example, notice that it's actually set up for substitution. It's not set up for elimination because we need x and y on the same side. So first thing I'm going to do is subtract 2x to the front so that now x and y are on the same side in standard form. I'm also going to need to multiply the bottom equation here by 4, or the top equation by 4, to get my y's to be the same. So that would give me negative 8x plus 4y equals negative 20. And the bottom is 8x minus 4y equals 20. And notice they all cancel out. And so I get 0 equals 0, which is true. So this one is a many solutions, which means if I would graph these two, they would be graphed on top of each other.